Hey, hello everyone, Rutik here, and today is our 24th day of Finding Job series. So let's start our today's day. Uh, Today I woke up at 7, did some exercise, and after that get ready and sat on my desk. Today I learn about very new concept because it's very new for me. I heard it first time. I didn't know that this kind of a thing also exists in JavaScript. But yeah, the concept called shallow copy versus deep copy. Yeah, it's pretty new. I didn't know about that. So let's start from the scratch. Let's start from the beginning. So we all know when we declare the any variables or store any data in JavaScript, we have two kinds of a data type. First one is a primitive, another one is a non-primitive. Primitive means variables like strings, numbers, boolean, null, undefined, etc. etc. are come under the primitive data types, and functions, object, arrays are that come under the non-primitive data type. So yeah, let's start with the primitive data type. So if I want to copy data in primitive data type, how I can do that? Means how can I achieve? So let's take an example. Let a is equal to 10, and I want to copy that data into b. So simply I can do let b is equal to a, so that the data inside the a assigned to the b. So when we console do the console.log of a and b, both are showing values 10. That means that when memory is created in JavaScript, where a is located to means the reference of a to the memory address 10, where 10 has been stored, and b also created new memory where 10 has been stored. So both have the value now 10 10. When I change the a to 11, b still remain 10 because they are independent values. If I change a, b didn't care about that. So they have, we can say they have a different reference. Like reference means when I create the variable like let a is equal to 10, that means a refer to the memory address where 10 has been stored. When I create that b is equal to a, that the memory of a means value of a assigned to the b, where the b create the memory address where the value 10 has been stored. So they have different values. So yeah, they have a different reference, different memory address in our JS server. Okay, so that is pretty easy. So we also call that value copy, but the case slight is different in non-primitive data, right? Let me tell you how it's work there. So if I create let's take an example. I create let object 1 is equal to I means open the parenthesis in which I write name is equal to Rutik. Okay, and I want to copy that object, so I write another object, let object 2 is equal to object 1. That means the value inside the object 1 has been copied into the object 2. Okay, but okay, that copy has been done. But when I change the anything, let's I change the object 2. So I change the object 2 dot name is equal to let's say I change it into the Pratik. So when I console.log the object 1, means I console.log the object 1 dot name, so it also get changed. Let me tell you why. Because when I create the another object, we know object 1 refer to the memory where name Brutik has been stored, and when I create the object 2, where again I use the same value, it it's not create another new memory for it. It's actually refer to the same memory. So object 1 and object 2 are referred to the same memory. They have only same memory address, only one memory address. Okay, they share the memory address. That means they share the reference. Means object 1 refer to the memory and object 2 refer to that memory. So they have same reference. Okay, that's why when I change something, if I change object 2 dot name, object 1 also change. If I change object 1 dot name, object 2 also change. And that type of a copy also known as a reference copy, and it's not a good practice. So avoid that problem or that situation, our shallow copy and deep copy comes in a picture. So let me tell you how they avoid this means this problem. So what shallow copy did, so let me take an example. So again, let's create an object. Let object is equal to name Rutik, and let object 2. Now I can do means I can use the spread operator. Using spread operator I am able to shallow a bit. Means when I now I like write like a let object 2 is equal to in parenthesis dot 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 object 2, object 1, sorry. That means the value inside the object 1 has been transferred to the object 2. Now they have the different reference. Okay, so when I change the object 2 dot name into the Pratik, object 1 dot name still be Rutik. It doesn't change, means they have different reference now. But here is one problem again. So what if I have the nested objects? So if object 1 is equal to name Rutik and address, another value address, where I again one object open where I write a city Pune, and I copied that object into the object 2. So when I change name, like I change in object 2 dot name, I change into the Pratik. In object 1 name has been name still Rutik, and here I am able to see name Pratik. But when I change the object 2 dot address dot city into Mumbai, the city also, the change has been reflected into the object 1, because the nested object still share the same reference. This is the problem occur in the shallow copy. So avoiding that problem, avoiding that nested reference problem, the deep copy comes in a picture. So deep copy actually create independent object. They have different reference. They totally not dependent on each other. They have independent. Both are the independent object. So let me tell you how we can do this. So we just simply write let object 2 is equal to json dot parse dot json dot stringify object 1. Now the object 1 and object 2 are completely different. If I change name in object 1 or city in object 1, object 2 have that current value, and if I change object 2 city or name anything, object it didn't affected to the object 1. So yeah, these are the shallow copy and deep copy. Let's revise it. So first we see the value copy that has been done by the primitive values. So where values are in copy, the reference are difference. Another we see the reference copy in non-primitive data type, where the reference are also same, the reference are copied, they both the variables share the same reference. Again we see the shallow copy, where only first level are copy has been done. The first level copy is independent. When it's get nested, then it share the same reference. And then we see the deep copy, where everything is independent, everything is copied. So yeah, that's it. That's it about the deep copy and shallow copy. Pretty new for me, but yeah, while learning it, it's seemed very fascinating. And after that I solved some problems around the stacks and queues. I learning about the stacks and queues. I solved real problems on DSA about that. And after that I had my lunch, and I build project feature. I work on the design part. Most of part is completed. I think from next week maybe I deploy my project. And after that I did some communication practice, applied some jobs today. And yeah, today is Saturday, pretty low, nothing, not any call, not any interview, nothing is going on, still learning. A little bit demotivating, but yeah, we know our task, our daily task, we had to be done, we have to be for achieving our goal, we have to be done this task daily. Yeah, so that's it for today. Bye bye.